So I missed one of the, two friction forces. The friction between the box 1 and box 2, which are actually on top of each other. I missed it because I was thinking, like our practice problem, they didn't have a friction force, but it's kinetic friction and they're moving, so they have a kinetic friction force between the two blocks on top of each other. And if you think about it, this block is being pulled by a pulley by box 3. So box 1 wants to stay and it will move towards the left. So the friction force will oppose this movement and will go to the right. So on box 2, opposing this kinetic friction between the two blocks, it has to go to the left. For C and D, it asks for the acceleration of block 3 and then the acceleration of block 2. These accelerations are the same because since block 2 is being pulled and is connected by a string to box 3, it is one system. It's a combined system. You can think of them as a kind of like this same entity. So M2 plus M3 times A describes this force that these two boxes are going through when this is being pulled down by the force of gravity. So if you just concentrate on 2 and look at the forces there, you get this equation thing, because the force of tension is pulling it down, so that's the biggest force, so it's M3G, because you see force of tension is equal to force of gravity. And then that is subtracted by the kinetic friction between the two blocks, and the normal force on that is M1G, because this is the force of kinetic friction between the two blocks and it's going towards the left. And if you look at the normal force on this block, you realize that it's just opposing force of gravity, which is M1G. So that's where you get that from. This tension force is also being diminished by the kinetic, the friction force between the floor that box 2 is on and the box. So the normal force on the box is equal to F1, the gravity of F1, and the gravity of 2. So it's M1 plus M2 times G, so you get that. So if you're solving for the acceleration for both box 2 and box 3, you simply divide both of them by the masses of the two blocks. You get acceleration equals M3G minus mu A M1G minus mu B, parentheses M1 plus M2 times G, all over M2 plus M3.